study erosion of beaches in the lab in small-scale models. And this is something that is also interesting because it allows to draw some conclusions. Usually these kind of experiences are very expensive. Strengths and weaknesses. Here in this case I have only weaknesses because the strengths were already summarized above. The weaknesses are, if you use gel containers, gel textiles, their resistance to abrasion may be low, and you may experience punctures and abrasion because waves sometimes throw over the dune cobbles, as I said. They may be vandalized, and also ultraviolet radiation, sunlight, which is particularly, it's particularly important in beaches because you don't have shower usually, and these are very effective in degrading in these structures, these containers, and once they are degraded you have to count on their natural stability, as I said. A gel container may roll down. A gel container cannot be expected to reach more than 5 feet in height, any single one, and then you can pile them. But of course, if you have to build a dune that is very high, of course, the solution has to be carefully studied. Let me see this application. Let me see this link. Maybe that there are some pictures here. This is a natural cobble beach, but it gives to you the idea of what is a cobble berm. And this is natural. And natural means, you have to expect that the size of the material of the berm is a larger grain size. And in some cases, the coverage of cobbles may be natural. And let me see if there are some other pictures. And this is, again, this is a natural cobble beach. It's interesting if you look in the background. You see that here you have the sand and then cobbles. So this is interesting. If you can find places where cobbles arise naturally, it gives you an indication of the kind of displacement, the kind of diameter that you may use. Let me see, I think there is another example here. And this is an example of erosion. And I think there should be some pictures. This is a sketch of an artificial dune. You see, they put the bags in the interior, in the core, and then they displaced some sand above them. And this is something, and you see that they put also vegetation. We will see that another way of protecting the dune is restoring vegetation. So just have a look at this sketch because you see they give to you the slope of the beach that they try to give and the slope of the dune. It's interesting to get orders of magnitude. And this is construction of cobble berms and an artificial dune. The artificial dune is behind here. You see that there are trees on the other side of the dune and brushes on the side, on the seaward side. And this is a typical configuration of dunes. In the landward side of the dune you find trees because they are less exposed to the spray. Here they are very close to the dune. Normally I would expect that they are a little bit behind. This is a completed cobble berm and artificial dune. You see that after restoring the vegetation, after the cobbles have mobilized a little bit, it looks quite natural. This is another sketch of protection. You see that there is sand here, and then they put cobbles over the sand here. The cobbles are protected seaward by big boulders to avoid that they are displaced into the sea. And then there is a riprap protection. Riprap means displacement of big stones in order to protect the dune. These are interesting examples that I suggest you to look at. So I think we can, okay. Beach nourishment, we already talked about it. And the most relevant issue is related to, we already mentioned that, the selection of the sediment size. You may be tempted to use sediments of larger size, much larger, of course, to resist to erosion. On the other hand, if it is too large, it doesn't look natural. The ideal solution is a bit larger, but not much larger. And also you have to take into account and to select carefully the location where the material is taken from, because if you take it from a very different location, then the color is different and doesn't look really natural. And strength reduces erosion, okay, perfect. May favor the development of an evolution of beaches that is close to natural, of course. And there is an ecological value in that, in beach nourishment. Weaknesses, they require periodic maintenance, and especially if we don't put hard infrastructure there, we need to replenish the beach once in a while. It can be eroded suddenly by just one extreme event, because, you know, it's beach nourishment. Beaches in their natural form, sometimes it's amazing. They may disappear with one event with a large record period. There is an impact to regional sediment transport, and okay, it can lead to removal of a large volume of offshore sand, because, why is that? Because very often, where do you take the sand? You go offshore and take the sand offshore, because it's from the same location, same sand. And of course, there is an impact. Even if you go to take the sand offshore, there is an impact. The wave behavior changes, so its waves are breaking more closer to the beach. So these changes are to be taken into account. And you know, there might be a severe impact on the ecosystem, because you put sand over it, and therefore, you know, there is indeed an impact. There is an impact where we take the sand from, and it can lead to steeper beach profiles, which can increase wave energy on the beach. Beach scrapping, this is extremely interesting. It's widely practiced here. And the rationale is very simple. As I said, the berm is formed during summer and removed during winter. In our locations here, this is what happens. So the idea is just remove artificially the berm at the start of the fall season, put the berm against the dune in order to protect the dune and in order the berm not to be removed. And then at the start of the tourism season, they go there, take back the berm in its natural displacement. Indeed, if you go during the winter in our beaches, you get amazed, because the configuration is completely different, and there is a dune which is not there during summer. And the dune is created by removing the berm, putting the berm landward as much as possible, as long as possible, as far as possible, in order to protect it. It seems to be a very good solution. I mean, it's very reasonable. The problem is that by scrapping the berm, you destroy the ecosystem, and then when you put it back again, the ecosystem is destroyed. And this has an impact, unfortunately. There is a strong impact because the ecosystem is going alive, because every year we change it. And even if we can't see the ecosystem in the beach, actually is there, and actually it has a role. It has a role in cleaning the sand, because the ecosystem removes nutrients from the sand. So it has a role in cleaning the sand, it has a role in cleaning the seawater. And it's a role that in some cases is very important. And therefore, if we destroy the ecosystem, we end up with a dead beach. There might be an impact on the quality of the beach and the quality of water, which is something to be taken into account. And strengths and weaknesses, let's see. It widens the beach for recreational use, and you know, of course, the beach is protected and therefore it's widened during summer. The aesthetic impact is very low, and it's very natural. I mean, the supply of sediment is natural and compatible, and it may have not any impact on the natural cycles of the coast, erosion and accretion. I mean, meaning that the beach is preserved, and there is an increased defense without the expense of importing volume of sand. It's very easy. And then it has to be weaknesses, it has to be repeated frequently, and temporarily interrupt sediment supply, and therefore there might be downdrift erosion. Okay. It's least effective in front of seawalls. Why is that? Because if there are seawalls, even if you put the sand against the seawall, it may not be protected by erosion. Modification or destruction of habitat. Offshore borrow areas may increase erosion rate, which means that borrow areas offshore means that you may take the sand from offshore instead of limiting yourself to taking the sand from the berm. In some places they think of moving offshore and take the sand even there, which is again what seems to be a reasonable solution. But if you deepen the ocean, you may increase the erosion rate of waves, and then you may adversely steepen beach profile. But still, it is very practiced, and I would say also very convenient from several points of view. Of course, one can say the beach, the natural behavior of the beach is destroyed. Actually, if you go to a managed beach, like here, and you go to a place where the beach is not managed, and there are several examples, even close by here, you see that there is a big difference. There is a big difference, and you clearly recognize that the natural behavior of the beach was destroyed. This is a price that we can pay, because the natural behavior of the beach is not so prone to tourism. So it's something that we can afford. What I would say is that we should keep some portions of beach that are not managed for what it's possible, because if not managing means that they disappear, clearly this is something that is to be carefully evaluated. But if it's possible, we should preserve some places where there is the presence of natural ecosystems, because this allows us to limit the impact of the portions of beach that are managed. Indeed, if you go along the beach in our region here, you see that there is a tension to that. Once in a while you find a portion of beaches that are not managed. On the other hand, I would like to say that we can afford the impact of a managed beach if it is carefully evaluated. Vegetation recovery. Again, keep in mind that if you put vegetation over a dune, if you put vegetation over a beach, the beach becomes less attractive for tourists. The tourists are attracted by a beach that is clean, well managed, without any spike, without any risk. But vegetation, by definition, is a risk, because there might be spikes, and there might be animals in the vegetation which are, not really dangerous, but annoying. And anyway, vegetation recovery is a very efficient way of recovering a dune. And first, you require to make a careful assessment of what could be zones of displacement of vegetation. And depending on the exposure to salt water, there are several levels of vegetation over a dune. I already mentioned the fact that the landward side is different from the seaward side, but even in terms of displacement along the side, you have zones which are more exposed, others that are less exposed. You have zones where you have more fresh water, the low zones, which are sometimes also those that are more exposed. You have the upper part of the dune that it's more, there is less storage of water. So you have to clearly identify, possibly with an interdisciplinary approach, what are the zones in which different type of vegetation may develop. Because of course, if you plant vegetation that is not sustainable for the given zone of the dune, the vegetation is going to die. Our aim is to plant there vegetation that can survive by itself, without any maintenance, without any service that could lower its sustainability. And therefore here there is a description of what you find landward, what you find seaward, etc. And what you have to look for is for the salt tolerance of the species that you may consider to plant there. Again, looking around, finding places nearby where there is vegetation is the best that you can do. And here you can see an example of a dune that is going to be revegetated. And you see that vegetation in its infancy is protected by access by humans and animals, because this is not a problem. If the dune is vegetated and humans are allowed to go there, you can clearly recognize where humans pass, because there is no vegetation there. And where they pass and there is no vegetation, there is erosion. You see that the paths across the dunes are eroded, because wind is terrible. In some places, you may find sidewalks, elevated sidewalks over the dune. In order to avoid the removal of vegetation by humans, they put sidewalks elevated. And I went last year in South Africa, where they are protecting the dunes with particular care. And indeed, I went over the dune jogging for kilometers over a suspended sidewalk. And this is an example, and you see how the vegetation behaves after a while. If we are successful, if there is no excess of people, if there is no excess of animals, then after a while, vegetation may grow up. You see that some plants are particularly protected, because we have to make sure that there is a mix of vegetation. We need to make a mix of more developed vegetation in terms of size, in terms of, because we have a primary vegetation, which is the kind of vegetation that you use in order to start. And then there is a more developed vegetation that needs to be planted in an already established environment. Like trees are a very developed form of vegetation. They cannot grow in zones that are exposed, they cannot grow by themselves. You first need to build a base vegetation, and then, if they are sustainable, trees. And here you see that there are different types of vegetations that are protected, in particular. And chicken wires are called in English this kind of I don't know how to say, net. Chicken wires. Okay, and of course you have also to carefully try to assess what is the water storage in the dune. In order to select the vegetation, it may be useful to try to dig into the dune and to see at what depth in the dune you have water, how much water do you have in different seasons, and the study of the groundwater behavior of the dune. It's very important, and it's something that is fascinating, but on the other hand is challenging. Okay, and that's it about, this is a very brief treatment of nature-based solutions. Of course, you can find on the web much more, and but I think that you can complete, if you're interested in this study by yourself. What you have to take into account is that for any nature-based solution, it's difficult to find a technical guidance. It's something that the first question for you is it possible to test it with a limited impact? I'm not finished. And with a limited impact on the environment, and etc. And if it's possible to test, of course, etc. I mean, with if you have time to afford testing a solution, and of course, if you can test it, it's a very good idea to start by small steps in order to check what's feasible, and therefore you have to particularly look for any description of other experiences. So find on the web, look around first of all in the same place, but look in the web for description of similar experiences. What happened? The description of failures is extremely important. Unfortunately, you don't find much records about failure. There are some agencies that got it and also report experiences of failure, but usually you only find experiences of success. Still, try to dig in the web and to find if there are reports, if there are sketches of what they did. This is today an amazing opportunity, because on the web you find a lot of things. Of course, you need to be expert in browsing the web, and you have to distill what could be useful for you. And of course, speak with colleagues that are already working on that, and look for experiences. But you will find not so many. And now they are increasing in number. But still, even when you talk about green cities, efficiency of green roofs, solution like green walls, we are trying in the University in Bologna green wall now. We already have a green roof in one of the buildings of the university. We have a green roof that has been operating already for, I think, 5-6 years. And now we are trying a green wall. A green wall is very interesting because it helps you to keep, to increase the isolation, the thermal isolation of the building. During summer it's really refreshing, during winter it's keeping the building warmer. And, but it is to be maintained, it's vertical, and therefore, you know, it's not so easy. You have to use some particular kind of plants, and then you have to be careful about humidity and other downsides. But it's, these experiences are increasing in number, as I said, but still they are not very frequent, and it's not so easy to find reports. And for some reason, given that these experiences have a limited technical content, they are just experiences, they don't get much attention from scientific journals. Because scientific journals are looking for theoretical development, for innovation presented in a quantitative way. So it's a kind of vicious, do you understand what I mean? Vicious circle. Meaning circolo vizioso in Italian. It's a kind of, I think it is spelled this way. Meaning that, you know, it's not very technical, it doesn't get attention from scientific journals, and if it doesn't get attention from scientific journals, it cannot be disseminated. So it's something that is not easy to explore. And also keep in mind that when you talk about nature-based solution, this is a sensitive topic. So if you say, people are very sensitive to that, because there is the feeling induced by the media that they are the future, but for some reason, agencies, politicians don't want them. And this is a drawback, it's an additional obstacle, because people, when you say they may be not effective, they get unhappy. So you have to be careful, it's a bit sensitive. I like when you say dams are needed, you get heavily criticized by people, so one has to be careful in saying that. And so the fact that it's sensitive, it's not making our life easier as technicians. An example which is much worse, it's climate change. It's very sensitive, and therefore when you talk about climate change, you have to be very careful, because people get really unhappy when you talk about climate change. Whatever you say. Okay, and now let me move to the next one. I take 10 minutes from you. Let me check what could be, the next lecture is not there yet. Let me check what could be the best way to move forward, because I have to make a selection, because I have a couple of alternatives. Just 1 second. Let me look into what's available in the book. Here it is. Let me see if I put climate change here. Okay. So, here I am in the page of, I think you have seen it, in my website. If you click on teaching, so this is my main page. If you click on teaching, I already mentioned to you this. You get the full list of my courses in the past years, and you get a couple of ebooks, evolving ebooks, and one of these, you have to scroll down. One of these is Coastal Engineering Made Easy. Here there is the full list of my lectures on coastal engineering, which is a list that is more extended with respect to what I taught to you, because it also includes mechanics of sea waves. It doesn't include a lecture that I would like to give to you on climate change. But let's see, we made here, we have these alternatives. Breakwaters, I would prefer not to speak about them. Nature-based solution is fine. There is a lecture on estimation of extreme wave height. So I prefer not to teach this. And the reason is that I think you already have had an introduction by Professor Archetti on that. It means that you have observation of wave height and you have to estimate the expected wave height for a given record period. And so I think you already had this. I'm not asking anything at the exam, but my feeling is that this lecture is giving to you more of what Professor Archetti taught to you. The reason is that the reason is that she has to optimize as I do. And therefore, I just wanted to, because this lecture starts from very far, from basic concept of probability theory, but I think it is an easy to read lecture. So my suggestion to you is just keep in mind that this is available on my website, and it will be available to you even after your graduation. If you need a reference, just keep it in mind, because I think it's a useful reference, and I think the treatment is very specific, meaning easy to understand. Now, if we skip this, what I would like, and maybe that in my last lecture we say something, but I would like to deal before that with another topic that is again descriptive, but I think it is extremely important, which is climate change. The lecture is still not here. I will put it here as soon as I have time. But let me start by taking it from another sequence of lectures here. This lecture is titled Climate Change and Water Cycle, and it contains a part that is explicitly dedicated to sea level rise. So I think this lecture is useful. It takes a couple of hours, so it's a bit long. Why it's useful? Because you know that today whatever you do in the environment has to interact with the problem of climate change. And this problem is very sensitive. As I said, whatever you say, you risk to be accused of something. But still, we have to deal with it. You can't avoid it. My decision in the past was to try to get rid of it as much as possible. In any of the consultancy activities that I was asked to provide. And the reason why I wanted to get rid of it is sensitivity. Because I really had to fight very hard, interacting with the audience, with the public. So I said, let me try to get rid of it. And this was about 10 years ago. I had to fight hard when submitting papers. They were systematically rejected. And so about 10 years ago, I decided to try to get rid of it. On the other hand, after 10 years, I must say that it's impossible to get rid of it. This is my conclusion. And therefore, what I would like to try now is to propose an innovative approach, which is to try to look at climate change in a very objective way, based on facts, reporting facts that are available on the web. Still, it's not easy because even if you report facts, you may be accused of cherry picking. Do you know what is the meaning of cherry picking? Cherry picking means cherries, you know what they are. And when you pick cherries, you try to select the best ones from the tree. You don't pick cherries just all of them. You try to select the most interesting ones. And even when you browse the literature, you could select the references that are that you like more. So when you present things in an objective way and people don't agree, they accuse you of cherry picking. Like, okay, you took only the references that that support your thesis, and therefore still it's not easy. But I'm making an effort to try to present it in a very factual way. And this lecture is written with this spirit. And also, I think that what's important in the context of climate change is to try to identify and to use as a support for the design the issues where people agree rather than focusing on the issues where people disagree. What is the big problem of climate change? The big problem is attribution. Attribution means, is it human-induced or not? This is the big problem, where people really fight. And even if the media say that the scientific community is agreeing 97%, there is this magic number that is proposed. In recognizing that it's human-induced, actually this is not true. The scientific community doesn't agree. We may say that the center of gravity is indeed in the part of people that think that it's human-induced, but there is still a large part of the scientific community who at least say, not clear to me. And this is the big fight. But as engineers, we may want to just get rid of this question. I don't care. I mean, as an engineer, I have to make design by taking climate change into account. I'm not required to make design for mitigation of climate change. I need to make design for adaptation. Keep in mind the difference between the two, because it's a fundamental difference. Mitigation means try to understand what are the causes and try to reduce climate change by opposing or removing these causes. So if I set strategies for a carbon-free economy, this is mitigation of climate change. Adaptation is different. It means there is climate change, I assess it, and I design strategies for minimizing the impact. Of course, we need both, but the specific task of the engineer, and this is what I'm repeating to everybody, is adaptation. It is nonsense to study mitigation alone. It is nonsense to study adaptation without the contribution of engineers, because this is precisely a task of an engineer. Mitigation is not. Unless we talk about geoengineering. Geoengineering means that you try to set up an engineering strategy to mitigate climate change, but their effectiveness and their popularity is still very low. So, unless we talk about geoengineering, the task of the engineer is adaptation. So what I'm trying to say now is, okay, let's focus on climate change. Try to assess its importance, its magnitude, and let's devise strategies in order to adapt to it, no matter what the causes are, because we need it in any case. Especially because mitigation may take centuries or decades. Adaptation may be reached in a shorter time scale. So this is my way today of approaching the problem with a constructive attitude. I tell you, it's really not easy, and this is the reason why, even if it's very descriptive, even if it's a topic that probably is so covered by the media, I decided also with the students to focus on it. And I think we can start next time. I just wanted to say you something. Last week I went to a conference, to an international conference, where it was in Vienna, where, this is the reason why I didn't teach, where we invited to speak Mario Monti, you may know the name. We invited him because he's very popular abroad. He's not very popular in Italy, but he's very popular abroad. And he spoke about the interaction between science and politics. It was a very interesting talk. By the way, it is on the web, and you just have to go if you want to see it, okay. If you're interested, just send me an email and give you the reference. And in order to get prepared to this speech, he wanted to know what was our position on climate change. And he recognized that as a politician, he had a vision of the climate change problem that was not really matching what the vision of scientists was. I think this was extremely interesting, and he took a lot of notes. And in fact, after his speech, he was challenged with a question on climate change, and he took some time, he looked at the notes, and I think he gave a positive reply. He said, let's not discuss if it's human-induced or not. Let's just say that everybody claims for, this is what he said, everybody claims for climate change adaptation, so we have also these movements today, in the past few weeks, the voices were very strong, but he said, let's keep into account that any country that has to adopt a climate change mitigation policy has to dedicate taxation to that. So it's very costly. It reduces the competitiveness of the country, and it goes in the pockets of the citizens because we need money. We need a lot of money for it. And I think he gave a very good reply because it's not a simple problem. I mean, everybody says